Alright, I promised 6 videos. Let's look at the 5th video, and this time around we're going to talk about integration of the form fx to the power of n f prime x. So what is the formula that we are going to explore on? It would be this. Let's look at the first one. Integration of sine x to the power of n cos x respect to x, and this should give you sine x to the power of n plus 1 over n plus 1 plus c. And why is this? We have taken sine x to be fx, therefore it should be fx to the power of n. And what do you get if you were to differentiate fx, which is equivalent to sine x? You get cos x. Using the formula that I have given you earlier, I should be expecting an answer of fx to the power of n plus 1 over n plus 1 plus c. Hence, given that sine x is fx, you should be getting sine x to the power of n plus 1 over n plus 1. Let's look at one example. Example 3 on page 35, part B. Integrate sine to the power of 4x cos x respect to x. Which one to be taken as fx? Of course, the one with power. Therefore, sine x is fx, and this should be fx to the power of 4. What then is cos x? Cos x is simply f prime x, because differentiating sine x gives you cos x. Using the formula given, I should be getting fx to the power of 5 over 5. And what is fx? One more time, it is sine x, therefore answer would be sine to the power of 5x over 5 plus c. Alright, what else do we need to know? Integration of cos x to the power of n sine x respect to x, and this should give us negative cos x to the power of n plus 1 over n plus 1 plus c. And how did we get such a formula? Again, the 1 per power will be taken as my fx, and therefore fx for this case would be cos x, and this should give fx to the power of n. Differentiating cos x should give me negative sine x. If I were to adjust my question in such a way, there's a need to adjust it back by putting a negative outside. So what do I expect to get? Using the formula given again, I should be getting fx to the power of n plus 1 over n plus 1 plus c. So looking at it, there was a negative in front, therefore this negative is necessary. Using formula, fx is cos x, hence cos x to the power of n plus 1 over n plus 1 would be what I get if I were to integrate accordingly. hence this formula. Let's look at one example. Example 3 on the same page, page 35, part C. Integrate sin x cos x to the power of 5 respect to x. Taking cos x to be fx, it should say fx to the power of 5. Differentiating fx, which is supposed to be cos x, I should get negative sin x. Adding a negative over here will tell you to also add a negative outside to balance things up. Therefore, answer would be negative fx to the power of 6x over 6 plus c. Moving on, let's look at integration of exponent x plus 1 to the power of n exponent x respect to x. Again, the one with power should be taken as fx. Therefore, for this case, it is fx equals to exponent x plus 1. Exponent x plus 1 to the power of n would give you fx to the power of n. Differentiating fx, which is supposed to be exponent x plus 1, would give you exponent x. Using the formula given, I should be expected to give fx to the power of n plus 1 over n plus 1 plus c as an answer. Hence, what should I fill up over there? It should be exponent x plus 1 to the power of n plus 1 over n plus 1 plus c. Let's look at one example. Example 2 on page 35. On page 34, part H. Integration of exponent x 1 plus 2 exponent x to the power of 4 dx. I will be taking 1 plus 2 exponent x as fx, hence that should give me fx to the power of 4. Differentiating fx, which is supposed to be 1 plus 2 exponent x, should give me 2 exponent x. This is what I got. In order not to change what is given in the question, I should be putting a half outside. So what do I write next? Half is just a number. Copy as it is. Perform integration on this part. I should get fx to the power of 5 over 5 plus c. Therefore, final answer would be 1 over 10, 1 plus 2 exponent x to the power of 5 plus c. Last formula to explore on for this video would be ln x to the power of n 1 over x dx. Obviously, the one in power is to be taken as fx. Therefore, fx for this case would be ln x, and ln x to the power of n would simply give you fx to the power of n. What do I get if I were to differentiate fx which is ln x, I should get 1 over x. So going with the formula given, I am expected to get fx to the power of m plus 1 over m plus 1 plus c. So what should I get as an answer? I should be writing ln x to the power of m plus 1 over m plus 1 plus c. Let's look at an example. Example 2 on page 34. Part end. You were given ln x over x respect to x. Indeed, this is a fraction, but we are not going to use the formula of f prime x over fx, because if I were to use this, fx would be x, and hence I should be seeing 1 on top, but it isn't a 1, so this shouldn't be the right formula. So what then should the formula be? Ln x over x, the x was what given? I'm going to rewrite it to the form of ln x multiplied by 1 over x. This time around, there isn't any power. So which do I pick as my fx? Of course, ln x, and hence it should only go with fx to the power of 1. Why did I do that? Because differentiating ln x gives me 1 over x. If this is what I have, I would be expected to give fx to the power of 2 over 2 plus c as an answer, and hence my final answer should be ln x squared over 2 plus c. Now that you have learned to use this formula, please complete the following tasks. Example 3 on page 35, and exercise D, odd numbered questions. Thank you, and the next video is coming up.